In this section, we will discuss confidence intervals for a population proportion. Let's first begin with a bit of notation for this section. We have that P is the population proportion of individuals in a specified category. Next, we take a sample, and our sample size is size n. Of those n individuals who are sampled, X is the number of individuals in the sample who are in the specified category that we're interested in. Finally, our P hat is the sample proportion of individuals who are in our specified category, and we can find P hat from this equation. P hat is X divided by N. In words, that is the number of individuals in the sample from the category divided by the total sample size. Next, there are a few assumptions we need to check before we begin to construct a confidence interval for the proportion. The first thing is that we have a simple random sample. Next is the entire population, so whatever population we're looking at, it needs to be at least 20 times as large as the sample that we took. Okay? The items in the in the population are divided into two categories. They're either in the category or not. And the sample must contain at least 10 individuals in each category. So if those four conditions are met, then we can construct a confidence interval using the following steps. First, we find our point estimate, P hat, and remember that is X divided by N. Next, we find the critical value corresponding to the desired confidence level. So in the phrasing of the problem, it will say, for instance, to 95% confidence level, 99%, 99.8%. Whatever that is, we can look it up in our table critical values for the student's t-distribution. So referencing this table that we have, we know if we were looking at, for instance, a 95% confidence level, we see the corresponding z-score is 1.96. Instead, if we were looking at a 99.8%, the z-score we'd be looking at here. And we can use this table if our confidence level is any one of these listed values. Now, if the problem lists something that's not from here, for instance, what if we cared about a 93% confidence level? We can still find it, but we can't use this table because notice 93% is not one of the listed values. If that occurs, if you're asked for a confidence level that's not in this table, then what you would do, we would go through to our other chart and do a process much like we've done in previous videos. So just as a quick sketch, if we were specifically trying to find the critical value that goes with a 93% confidence level, remember 93% confidence is that we've got the middle 93%. But this chart only gives you all the way to the left up to that point. So the chart doesn't just give me this section. Instead, it gives me all the way to the left up to this point. So in order to visualize that, I need to realize that the remaining 7%, and remember, we're going over this a little bit fast because we've seen this in previous videos. You can go back and watch it in more detail. But we know the remaining 7% is split halfway between here and here. So I've got I've got exactly 3.5% here, 3.5% here. So when I actually use this chart, I'm going to have 3.5 plus 93%. That's 96.5% accounted for at that point. Now, as a decimal, that turns into 0.965. So I would look inside the area. Remember, now I've got area, so I'm looking in the middle and then finding the z-score. I'm going to look to see where do I see something closest to 96.965, and that's my z-score. And it looks like this is the closest I'll get, 0.9649. That corresponds to a z-score of 1.81. So on the off chance your confidence level is not one of the ones listed here, you know the process of how you could find it using the other chart. Okay. So we find the critical value in one way or another. Next, we compute the standard error. and this is the square root of p hat times 1 minus p hat, all divided by n. Then you find the margin of error by taking the critical value you found in step 3 and multiplying it by the standard error you found in the critical value found in step 2 by the standard error by step 3, listed here in our mathematical notation. Finally, once you have the margin of error, the confidence interval is just your point estimate from step 1 plus or minus the margin of error from step 4. And in notation, that's p hat plus or minus the critical value times the standard error. Now we do have a rounding note here. When constructing confidence intervals for a proportion, round the final answer to 3 decimal places. Now so far we have learned, this is our third confidence interval. We've learned the confidence interval for the mean when the standard deviation is known, the confidence interval for the mean when the standard deviation is unknown, and finally this one, confidence interval for a population proportion. And each of those 3 different approaches to the confidence interval has a different rounding note. So do go back in your notes, find the different rounding notes that are listed, and keep track of when do you round to so many decimal places per strategy. So keeping those formulas in mind, we will now go to our first example. It says find the point estimate, the standard error, and the margin of error if x is 46, n is 97, and our confidence level is 99%. Let's begin with our point estimate. The point estimate's formula is p hat is x divided by n, so for us, that is 46 divided by 97. Next, we find the standard error. Following this formula, I'm going to put my value for p hat in. And now we calculate this. And as I need to wait until I get my final answer, in this case to round for population proportion confidence intervals to 3 decimal places, I'm going to leave quite a few of the decimals since I'm still in my intermediate steps. So we've got the point estimate, we've got the standard error, next we'll do the margin of error. We know from our previous page the margin of error is the critical value taken from the confidence level times the standard error. Now we already have the standard error, so I just need the critical value. My confidence level is 99%. And luckily for us, 99% is one of the listed confidence levels from our second chart here. So I see the corresponding critical value is 2.576. And we get these values. Now, as all of these are intermediate calculations, I left quite a few decimal places. If this was actually asking me for the confidence interval at the end, then my final answer I could round to 3 decimal places for the population proportion. So next we're asked to construct a confidence interval with a confidence level of 95%, x is 125, n is 317. So basically I have to find all the things that we did in our previous example and then put it together where the final step is the confidence interval, remember, is the point estimate plus or minus the margin of error. So we've already seen an example where you find point estimate, standard error, margin of error. I would encourage you to now find each of these things on your own, pause the video, work out these, and even find the confidence interval, and then unpause to check your work. So here, finding the point estimate, we know it's the number in the sample who are in the category, which for us is 125, divided by the total sample size, which is 317. That rounds to about 0.394321766656. Next, I find the standard error using its formula, typing this into the calculator, and we get 0.027448838. Next, I find the margin of error. I need my critical value. The critical value is based on the confidence level. This is 95%, so let's see if this is one of the known confidence levels listed in the table. We see 95% is listed along with its critical value of 1.960, so we'll record that. So we get that as our margin of error. Finally, the confidence interval will be the point estimate plus or minus the margin of error. And if we want to write that in interval form, we know for our final answer we should round to 3 decimal places. So I get this value rounded to 3 decimal places is 0.341. That's when I subtracted the margin of error. Now I go to the point estimate and add the margin of error. Rounded to 3 decimal places, that's 0.448 will be my confidence interval for this population proportion. Next, we have an internet service provider sampled 540 customers and found of that sample, 75 of them experienced an interruption in high-speed service during the previous month. First, we need to find the point estimate for the population proportion. Now, just reading through this context clue, the population proportion, confidence interval for the proportion, that tells me we're using the method found in this video. And we want to be careful to practice distinguishing that now that you've learned 3 different confidence interval methods. Based on the wording of the problem, you need to be able to recognize, is this a confidence interval for the population mean when the standard deviation is known? First thing that we learned. Is it a confidence interval for the population mean when the standard deviation is unknown? That was the second thing we learned. Or is it the content of this video, confidence interval for a population proportion? Okay, so we know the point estimate, our p hat, is the sampled in the category divided by the overall sample number. So for us, that is 75 out of 540, which I'm going to keep quite a few decimal places since I'm just in an intermediate step, but I know it's about 1.38889. We know in this method at the end for the confidence interval, our last step, we round things to 3 decimal places, but until then we're going to keep quite a few of the decimal places for our intermediate calculations. Part B asks us to construct a 90% confidence interval for the proportion of all customers who experience an interruption. Now we know to do a confidence interval there's actually quite a few things involved. I need the point estimate, which I have here, but then I need the standard error in order to find the margin of error. In order to find the margin of error, I need the critical value that corresponds to the 90% confidence interval. And then once I have the margin of error and my point estimate, I know the confidence interval is the point estimate plus or minus the margin of error. So let's begin to find those things in an orderly way. And all of these steps are outlined here in this page of our notes, step by step. What do you need to do? We've already got the point estimate, so next we're going to find the critical value. Then we'll find the standard error. Then we'll find the margin of error. And then our final step is point estimate plus or minus margin of error. Okay, so our critical value for 90%, if we look at the chart, we look at the confidence level, we see 90% is listed. The critical value is 1.645. Okay. After we have the critical value, we next compute the standard error, following the formula here. And keeping a few of the decimal places, since we're not at the final stage, will give us about this. Next, the margin of error, which is found by taking the critical value that we found above, 1.645, times the standard error, which we just found, multiplying these two together, and we'll get our margin of error. And then finally, to put it all together, we know the confidence interval is the point estimate plus or minus the margin of error finding our interval and rounding to 3 decimal places. We get 0.114, comma, 0.163 when rounded to 3 decimal places, and that will be our confidence interval. Now remember, this range represents our proportion, so the part of the whole, so 0.114, 0.163. If we were to rewrite that in context, this 0.114, when you move the decimal place twice, that turns it into a percentage. That's saying 11.4% to 16.3% of the high-speed service or the high-speed internet users would experience an interruption in service. So our confidence interval is saying we expect between 11.4 and 16.3% of customers to experience an interruption. So for part C, it says the company's quality control manager claims that no more than 10%, so no more than 10 is 10% or fewer of its customers experience an interruption. Does the confidence interval contradict this claim? So is our confidence interval saying something different than the quality control manager? And here we would say yes, it does contradict it, because we expect between 11.4 and 16.3 experience outages, and the quality control manager is saying 10 or less should experience outages. Our last topic of this section of notes is finding the necessary sample size. So let's say we've got a desired margin of error and we have a specific confidence level we're looking at. Then what is the sample size needed so that the confidence interval for the proportion will have that margin of error at that confidence level? So we have two different formulas. One if a value for p hat is available, one if no value of p hat is available. Let's look at the first formula. The first formula says the sample size we should take is equal to p hat times 1 minus p hat times our critical value, and remember that comes from the confidence level we're looking at, divided by the margin of error, so m is our margin of error, and then the critical value divided by the margin of error is squared, and then multiplied by the previous. Now the second formula should be used if we don't have the value for p hat, and that formula is our critical value divided by the margin of error all squared, then times 0.25. Now we've got a rounding note in both of these cases. No matter what we get, if it's not already a whole number, if it's a decimal value, you have to round up to the next whole number, regardless of normal rounding rules. So in our next example, we've got a medical researcher wants to construct a 99% confidence interval for the proportion. So here we see our phrase proportion. Since this is for the proportion, it makes us think of one of these two formulas at this point, of knee surgeries that result in complications. It is suggested that 8% of knee replacement surgeries result in complications. Using this estimate, what sample size is needed so that the confidence interval will have a margin of error equal to 0.04? So I'm going to record a few things. For us, m is our margin of error, that's 0.04, that was told to us. They said we're using this estimate of 8%. Remember, 8% is a part out of the whole, 8 out of 100, or as a decimal, 0.008. So my p hat, my estimate of complications that would occur, is 0.08. Since p hat is known, I'm going to use the first formula. The only other thing I see I need is my critical value. The critical value comes from the fact we want a 99% confidence interval. Let's look to our chart to find this. A confidence level of 99% corresponds to a critical value of 2.576. So then following the formula, the sample size needed is my p hat 0.08 times 1 minus 0.08 times my critical value of 2.576 divided by my margin of error 0.04 all squared. And I know whatever I get here, I'm going to round it up to the next whole number if it's not already 1. Typing it into the calculator, I get this value. I know I have to round up to the next integer. So that rounds to give me, I should have a sample of 306 at minimum. Now, in part B, it says estimate the sample size if we did not have the estimate of p available. Now, looking back at our formulas, we see this would be a case for our second formula because we have no estimate of p. So it's 0.25 times our critical value, which we found is 2.576, divided by our margin of error of 0.04, all squared. Typing in this to the calculator, we get this. Rounding to the next integer, we get 1,037. Should be our minimum sample size. So as always, if you have questions, don't hesitate to reach out via our campus communication, and I'll be happy to help you.